This is the story of how Marie Curie became the most famous woman in the history of science. Along with her husband, Pierre, the pair were the first scientists to deeply research a strange new phenomenon that Marie called radioactivity, the discovery of which led to them spending 4 years working day in, day out in a derelict shed, refining literal tons of uranium ore residue, and eventually managing to discover not one, but 2 previously unknown radioactive elements, which would eventually be used in applications ranging from treating cancer to nuclear weapons. She lived an amazing life that has been described in multiple biographies. The first, published shortly after her death, was written by her youngest daughter, Eve Curie, and the most recent was written by the award-winning science writer David Nobel, who I was lucky enough to interview to help me tell this incredible story. Let's dive into the tale of how Marie Curie changed the world. Marie Curie was born Maria Skłodowska in 1867 in Warsaw, Poland, right in the middle of a 123-year period where Poland had ceased to exist as an independent country, as it had been divided up between surrounding nations following various conflicts.
So her family was under Russian domination, which they felt personally and keenly because they were staunchly Polish in their culture and traditions and proud of it. But they couldn't speak their own language in many public places, including at the school where her father taught and the school that she attended. So there was a real tension all the time about that clash of culture.
Maria's family were proud patriots who continued to speak Polish at home. Her parents, Władysław and Bronisława Skłodowscy, were both highly intelligent teachers who raised Maria in an environment that encouraged her curious scientific mind, as well as giving her a deep love for her home country. Despite being forced to speak Russian at school, she excelled in her studies and became proficient in maths and physics. It was obvious from an early age that she showed great potential. From reading Ev's book, it's clear that there were 2 powerful forces that drove a young Maria through life: her love of science and her love for Poland, which led to a disdain of her Russian oppressors. Ev described a typical walk to school for Maria and her friend Kasia. In the middle of the Saxony Square was a pompous obelisk surrounded by 4 lions and bearing, in Orthodox letters, the words, "To the Poles faithful to their sovereign." This tribute from the Tsar to the Poles who had betrayed their country and made themselves allies of the oppressor was an object of disgust to the patriots, and their tradition was to spit every time they passed the monument. Maria finished school on the 12th of June 1883 and was awarded a gold medal for her academic achievements. Laden with Russian prize books which she loudly declared to be horrible, as it was her last day, what did she risk? She left the school in Krakowski Boulevard forever, escorted by her father, whom her success had overwhelmed with pride. Władysław took his family on a year-long holiday to the countryside to escape the stresses of Warsaw. Upon their return, Maria wanted to continue her studies, but the Russian occupiers didn't allow women to attend university. In response to this, many Polish professors secretly taught students in their own homes and other underground locations, and as a result, the clandestine organization became known as the Uniwersytet Latający, or Flying University. Maria joined and took lessons in anatomy, natural history, and sociology. The disciples gathered to the number of 8 or 10 at a time and took notes. They passed pamphlets and articles from one to the other. At the slightest noise they trembled, for if they had been discovered by the police, it would have meant prison for all of them. The Flying University courses helped to satisfy Maria's love of learning for the time being, but she had her eyes set on something greater. She wanted to go to the prestigious Sorbonne University in Paris, where some of the greatest scientists in Europe were working, and where women were allowed to attend as students. Her goal was to get the best education that she possibly could, and then return to Warsaw to teach the young men and women in the latest science, her own way to keep the Polish spirit alive and prosperous in the youth of her country. But there was a problem. She didn't have enough money to go there. She decided to make a deal with her older sister, Bronia, who also wanted to go to Paris to study medicine. Maria would find a job with a wealthy family in Poland, teaching their children, and sending as much money as she could to Bronia, who would travel alone to Paris for her education. As soon as Bronia had graduated, she would find a job and would financially support Maria's education in Paris. For the next 6 years, that's exactly what they did. Maria sent every bit of income she could to her sister in Paris, while she patiently waited for her turn. Then, at the end of 1891, her time finally came. How did she take to life in Paris initially when she first got there?
She seems to have taken to it immediately. At first, she was living with her sister, who had preceded her at the Sorbonne and become a medical doctor, and was married to to a Polish expatriate, in fact, who was also a practicing medical doctor. So Marie was living with them while going to school, but it was a big distance to cover every day. She wasn't close to her laboratory and classes, and there was too much socializing going on in the apartment. So they helped her get a little walk-up garret flat in the Latin Quarter, and then she was really happy living this Spartan existence, forgetting to eat, being completely swept up in the ability to think about science all the time. Her French was very good. She'd even been a French tutor in Warsaw, but it got a lot better of necessity soon after her arrival.
Maria couldn't have been more excited to dive into her studies. When she went to register at Sorbonne University, on the registration form she decided to write her name in the French style, Marie. Marie was a keen student who worked as hard as she could on her education. She had only one focus, to obtain not just one master's degree, but two, and she was successful in both. Marie obtained her first master's in physics in 1893 and her second master's in mathematics in 1894. She still intended to return to her home country to teach, but she wasn't finished with Paris just yet. The call of scientific research remained.
Yeah, so she'd been given a chance to do an industrial study that would actually pay her for her research. This was arranged by one of her professors who thought highly of her. And it was an area she had very little experience in. So a Polish friend of hers offered to introduce her to this other scientist, a French scientist, who had considerable experience with magnetism.
I have an idea, Yusuf Kowalski said to her after some moments of reflection. I know a scientist of great merit who works in the School of Physics and Chemistry in the Rue Le Mans. Perhaps he might have a workroom available. In any case, he could give you some advice. Come and have tea tomorrow evening after dinner with my wife and me. I will ask the young man to come. You probably know his name. It is Pierre Curie.
And then it turned out that she and Pierre discovered animal magnetism for each other, and fairly quickly fell in love. And she was conflicted. She really didn't want to stay in France because she felt compelled to go back and to teach in her home country. But between her feelings for Pierre and the fact that there seemed to be so much more opportunity for her to pursue scientific research by staying in France, that she decided to stay. Although she said it was a great grief to her to remain forever in Paris.
So, who was this Pierre Curie? He was a French scientist of genius, very nearly unknown in his own country, but already highly esteemed by his foreign colleagues. Pierre had obtained a bachelor's degree in science at the age of 16 and a master's in physics at 18. By the age of 21, he and his older brother Jacques had announced the discovery of a phenomenon they called piezoelectricity, whereby certain materials generate an electrical charge when subjected to mechanical stress. In other words, squeeze or stretch the crystal and it can make electricity flow. Their experimental work led them to invent a new apparatus with many practical uses, piezoelectric quartz, which measures small quantities of electricity with precision. In 1895, Pierre and Marie got married. Marie wrote a letter to her school friend Kaja, which she ended by saying, "When you receive this letter, write to me, Madame Curie, School of Physics and Chemistry, 42, Rue Le Mans. That is my name from now on." This became the name that Maria Skłodowska was known by for the rest of her life and beyond. Madame Curie was now focused on scientific research alongside Pierre. She wanted to obtain her doctorate, but what to research? Well, in the year of the Curie's wedding, a German physicist called Wilhelm Röntgen made an incredible discovery. He was experimenting with cathode ray tubes, which are essentially glass vacuum tubes with a couple of electrodes inside them. During his experiments, Röntgen wrapped a cathode ray tube in black cardboard to prevent interference from visible light, and noticed that when he switched on the current, nearby fluorescent screens started glowing. He realized that some invisible rays were radiating out from the tube and passing through the cardboard. When he investigated further, he found that certain objects held between the tube and the screens seemed to block the rays and leave a shadow. The most shocking revelation was that when his wife held her hand between the cathode ray tube and the fluorescent screen, it created a ghostly image of her skeleton. Röntgen named the mysterious rays X-rays, and the scientific community quickly became obsessed by them. Röntgen himself would go on to win the first ever Nobel Prize in Physics in 1901 for his discovery. One scientist who took a keen interest in X-rays shortly after Röntgen first announced them was the French physicist Henri Becquerel, who had previously done a lot of research into phosphorescence, the property whereby if you expose certain materials to light, the material starts to glow. When he heard about Röntgen's discovery, he began investigating whether these X-rays were also being emitted by various phosphorescent materials. He layered some photographic plates with coins and other objects, then wrapped them tightly in black paper. He then exposed some uranium salts to bright sunlight, and once they were phosphorescing, he placed them on top of the photographic plates. When he developed them, he found that they had exposed the plate, and that there were shadows where the coins and other objects were. It seems that he discovered Röntgen's X-rays emanating from phosphorescent uranium salts. But then, something unexpected happened. One cloudy afternoon, it was too dark to get the uranium salts to phosphoresce, so he left them in a drawer on top of some of the photographic plates that he'd wrapped up previously. On a whim, he decided to get these plates developed as well, and found that these plates had also been exposed, and that the shadows were just as clear as the previous plates. Shortly afterwards, he repeated the experiment with some uranium salts that weren't phosphorescent, and he found that they did the exact same thing. The rays that were coming off of the salts had nothing to do with phosphorescence. They were spontaneously coming off of the uranium itself.
So he didn't know what that was. He called it uranic rays. And he was excited, but people were still so caught up with X-rays that they didn't really pay a lot of attention to these uranic rays. And that's the subject that Madame Curie chose for her doctoral dissertation, partly because it was a new area that was not being entered by everybody else, and because her husband's discoveries and instruments that he had built could actually be used to study the phenomenon.
Pierre asked the director of the School of Physics for some laboratory space for his wife, but the only room that they were willing to provide was pretty meager. It was a kind of storeroom, sweating with damp, where unused machines and lumber were put away. Its technical equipment was rudimentary and its comfort nil.
They did not have ideal laboratory conditions by any means.
Marie wasn't deterred. Her first goal was to measure the power of ionization of these uranic rays, or, in other words, how well the rays are able to turn the air around them into an electrical conductor. To do this, she needed some very sensitive equipment that was able to measure tiny changes in current. Luckily for her, she was well acquainted with a couple of physicists who had invented such a device, Pierre and Jacques Curie. Here's how the apparatus worked. Marie would spread some powdered sample on this plate B, which was connected to a battery, so that a potential difference was created between the two plates. The radioactive sample would ionize the air between the two plates, allowing a current to flow between them. This current would pass into an electrometer, E, where it would rotate a small needle that was attached to a circular mirror. A light shining on the mirror cast a bright spot onto a nearby ruler. When the mirror rotated, the spot moved along the ruler. Also connected to the electrometer was a thin blade of piezoelectric quartz, which had a small platform hanging off of it, which you could load up with weights. When gradually adding weight to the quartz would be stretched, which created a secondary current that would eventually counter the first current caused by the sample. This would cause the mirror to stop rotating and the spot to stop moving. Eventually though, as the sample ionized more of the air, the first current would increase further, and the spot would start moving again. By timing the duration that the spot remained motionless, the current generated by the sample could be calculated. A more radioactive sample would ionize the air more rapidly, resulting in a larger current, so the spot would remain motionless for a shorter amount of time. As you can imagine, this whole method required a very steady hand and a lot of patience.
She tested every known compound of uranium and uranium itself, so she had solid data and could show that the current was directly proportional to the amount of uranium in the sample.
Because this was the only thing that affected the strength of the radiation, she hypothesized that the radiation must be coming from the uranium atom itself. Marie suspected that other elements might also give off similar rays to uranium. She decided to investigate every other known element, and eventually she found that thorium also spontaneously gave off these rays. The physicist had been right. The surprising phenomenon was by no means the property of uranium alone, and it became necessary to give it a distinct name. Madame Curie suggested the name of radioactivity. Chemical substances like uranium and thorium endowed with this particular radiance were called radioelements. Marie then investigated different minerals to measure their radioactivity, and she noticed something strange.
And she quickly came upon one that registered far more activity than pure uranium. And her immediate thought was, there must be another element that generates these rays, and it hasn't been discovered yet.
This undiscovered element must be present in very low concentrations, which explained why it had never been found before. Also, to give off such intense radioactivity, it must be significantly more radioactive than either uranium or thorium. When talking to her sister one day, she said, "You know, Bronya, the radiation that I couldn't explain comes from a new chemical element. The element is there and I've got to find it. We are sure. The physicists we have spoken to believe we have made an error in experiments and advise us to be careful, but I am convinced that I am not mistaken." As for Pierre Curie had followed the rapid progress of his wife's experiments with passionate interest. Without directly taking part in Marie's work, he had frequently helped her by his remarks and advice. In view of the stupefying character of her results, he did not hesitate to abandon his study of crystals for the time being in order to join his efforts to hers in the search for the new substance. The pair spent all of their time trying to devise a way to isolate their radioactive element. The uranium ore that they were investigating, pitchblende, was 4 times more radioactive than pure uranium. Due to its high radioactivity, they estimated that the unknown element probably made up about 1% of pitchblende.
Then the material had to be broken down chemically, and they were both physicists. This was not their métier, that they could figure this out alone. So they had a lot of help from chemist friends.
All minerals are made from a variety of elements with different chemical properties. The Curie's goal was to chemically separate the mineral down into its individual elements by sequentially reacting it with different reagents that would each target the different elements that were present. They'd start by dissolving what they could in an acid. They could then filter off the insoluble solid that remained. From here, they would have 2 paths to follow: the solution and the insoluble solid. For the solution, they could add a reagent to precipitate out a different insoluble solid. For each solid they obtained, they would redissolve them in different solvents, then add another reagent to precipitate out something else. They could repeat this over and over again, further separating the components of the pitchblende. After every single reaction, they would measure the radioactivity of each product they formed to follow where the radioactive element was ending up. By discarding the non-radioactive products, they could focus on experimenting with the radioactive products until they were left with a pure element. They began their experiments on the 14th of April 1898, and they worked continuously over the next few months. It didn't take long before they found something unexpected. When measuring the radioactivity of some of the products of their reactions, they found that two chemically unique products were both highly radioactive. Now, this could mean one of two things. Either the radioactive element was still distributed between the two products, which seemed very unlikely due to their vastly different chemical behaviors, or there were not one, but two previously unknown radioactive elements in the pitchblende, one in each of these two products. By July 1898, they were able to announce the discovery of one of these substances with certainty.
And the first one that they announced, they named polonium, after Poland. And it was the second one that they named radium, which seems to be a term directly related to radioactive radiation. But just recently, I learned that in Polish, the word for joy has that same root. Now, they never said why they named radium. They said that polonium was for the homeland of one of us, but they didn't make any similar explanatory statement when they announced the discovery of radium. So maybe she was thinking of both things.
This was incredible work, but there was a problem. Despite knowing they were there, they still hadn't been able to isolate the elements in any form, and without them, many scientists would remain skeptical that they even existed. During their experiments, Pierre and Marie found that the polonium could always be found as a tiny trace within the bismuth extracted from the ore, indicating that the two metals were very chemically similar, and thus very difficult to separate. Similarly, the radium was always found as a trace within the barium extracted from the ore. They realized that their original suggestion that the unknown element made up around 1% of pitchblende was way off. The actual amount was around 0.0001% at most. They were going to have to process literal tons of the ore to get enough of the elements to prove their existence. Sadly, there was no way they could afford it. They didn't even have enough money for a proper laboratory, let alone such a huge amount of an expensive mineral. However, they came up with a clever solution. Pitchblende was used industrially to extract uranium oxide for the manufacture of green-tinted glass. Once the uranium oxide was extracted, the residue from the ore was pretty much useless and was often dumped in nearby forests as waste. But it was this residue that would contain the precious polonium and radium that the Curies were after. So they didn't need to buy the expensive pitchblende. They could just buy the relatively cheap residue. There was a pitchblende mine in Austria, and after contacting them, the Austrian government decided to present a ton of residue to the two French lunatics who thought they needed it. While this first ton was being shipped over, they needed to find a bigger space to process all of this material. Even after everything they'd achieved so far, the university still wouldn't provide them with a laboratory. Instead, they found a disused and derelict shed on the campus that had long ago been used as a dissecting room. The place was in a terrible state. In the summer, it got stiflingly hot. In the winter, it dropped to freezing temperatures. When it rained, the roof leaked. However, as Ev said, the shed had one advantage. It was so untempting, so miserable, that nobody thought of refusing them the use of it. As soon as their pitchblende residue arrived, Pierre and Marie got to work. They decided to divide and conquer. Marie would focus on the chemical processing of the ore to try and isolate radium, which seemed to be much more radioactive than polonium was, so it was a lot easier to track. For now, polonium would have to wait. Meanwhile, Pierre would focus on trying to investigate the properties of the radium that Marie was able to extract. It was exhausting work. Marie would later write, "I sometimes passed the whole day stirring a boiling mass with an iron rod nearly as big as myself. In the evening, I was broken with fatigue."
The labor was tremendous, but she was highly motivated. And they were able to break it down more and more and more. And then by the end, they were doing this fractional crystallization, just get the most radioactive crystals out of it. And on they went.
Day after day, they worked together as a team, helping each other however they could with their experiments, while simultaneously raising their two daughters, Irène and Ève. Very, very gradually, they began to concentrate the radium found within the pitchblende residue. Eventually, a young French chemist called André-Louis de Bierne took an interest in the Curie's work. The couple explained their methods to de Bierne and challenged the young chemist to see if he could find any other radioactive elements in pitchblende. It didn't take long for him to succeed. In October 1899, he announced that he'd found a third radioactive element. He wanted to name it in honor of the Curie's radium, so rather than using the Latin root as they had, he chose the Greek word for ray, actis, and named the element actinium. By 1902, after 4 years of backbreaking work and after processing tons and tons of pitchblende residue, Pierre and Marie Curie had managed to isolate a whopping 0.1 grams of pure radium chloride.
Right, not radium, but a compound, which was mostly the chloride part, right? But it was enough to get a spectrum and to be able to say, this is a new element.
It was a striking substance that spontaneously gave off a pale blue glow, and it truly was beautiful to behold. It was also over 1 million times more radioactive than uranium. Despite all the backbreaking work, the pain, the exhaustion, Marie would later write of this time, "And yet it was in this miserable old shed that the best and happiest years of our life were spent, entirely consecrated to work." Marie spent the next few months writing her thesis, and on the 25th of June 1903, she became the first woman in French history to be awarded a doctoral degree. And how well deserved it was. How many doctoral theses describe the discovery of 2 new elements? A few months later, the Royal Society in London awarded the Curies the prestigious Davy Medal, which had previously been awarded to scientists such as Dmitri Mendeleev for his groundbreaking work establishing the periodic table, or William Ramsay for his genius discovery of argon. Marie was the first woman to receive a Davy Medal. Later that year, it was announced that, for their pioneering work in the field of radioactivity, the 1903 Nobel Prize in Physics was to be shared between Henri Becquerel and Pierre Curie, but not Marie. One member of the Swedish Academy, Gösta Mittag-Leffler, strongly disagreed with this decision, so he reached out to Pierre beforehand about his wife's snub. Pierre wrote to the Academy and said, "This would be a great honor for me. However, I should very much like to share the honor with Madame Curie, and for us to be considered jointly in the same way that we have done our work." After reflection, the committee agreed to include Marie, making her the first woman to be awarded a Nobel Prize. The Nobel Prize in Physics was a blessing and a curse for the Curies. They received some much-needed prize money to help fund their research. In addition, the Sorbonne finally recognized the Curies' great work and made Pierre a professor, giving him a full laboratory where Marie would work as chief of operations. However, with the Nobel Prize also came the burden of international fame.
Yes, so the Nobel Prize brought them all this attention, which they didn't want, kind of stupid attention. They were scientists, and what was interesting to them was the science and not their marriage or their child or their cat, all the things that got picked up on in the popular press.
A few months after their prize, in a letter to her brother, Marie said, "People are keeping us from work as much as they can. Now I have decided to be brave and I receive no visitors, but they disturb me just the same. Our life has been altogether spoiled by honors and fame." Just 3 years after their Nobel Prize, tragedy struck.
In 1906, when they were really in a very good place professionally and personally. They had two daughters, and they had received some very nice attention as a result of the Nobel Prize, so that they were really in a community of scientists, a global community of people interested in this new field of radioactivity. And Pierre had now attained a professorship at the Sorbonne, and in a most regrettable street accident, he was crossing a very busy street on a rainy day, and perhaps not looking where he was going, and one of the horses on a very heavy horse-drawn wagon knocked him down.
Here's Ev's description of what happened to her father in the next few moments. Pierre was down, but alive and unhurt. He did not cry out and hardly moved. His body passed between the feet of the horses without even being touched, and then between the two front wheels of the wagon. A miracle was possible. But the enormous mass, dragged on by its weight of 6 tons, continued for several yards more. The left back wheel encountered a feeble obstacle which it crushed in passing. A forehead, a human head. The cranium was shattered and a red viscous matter trickled in all directions in the mud. The brain of Pierre Curie.
A death like that, so unexpected in the course of an average day, it was horrible for her. She was 38 years old. They had a genuinely loving marriage. She has these 2 young children, and her life, her professional life, might have ended at that point. And the bizarre thing is that the faculty of the Sorbonne recognized that she was the best person to take over the laboratory. And they gave her that opportunity and his professorship. So that made her the only woman in the world with that kind of position. And very soon, that position made her a magnet for other women who wanted to pursue careers in science or were particularly interested in this new field. And there were very few places you could go as a student scientist to gain experience in radioactivity. And the number of women who passed through her lab was really remarkable. It's about 45 women, some of whom did really fantastic things. You've probably not heard of them, but the experience of working with her and then what they were able to do in their home countries. Several went on to be the first female professor in the countries they had come from. So her impact was immense. You know, when you actually learn about her, it's so much more extraordinary than you even thought. And then, as I said, her influence has not died with her. It remains strong.
By the time Pierre died, it had been 8 years since the Curies had started working in their crumbling shed, and what they had achieved together was nothing short of amazing. They introduced the world to radioactivity, as well as the elements polonium and radium. But the story doesn't end there. Marie would go on to do so much more, including winning another Nobel Prize in 1911 and building a portable X-ray vehicle to drive around field hospitals during World War I. If you've made it this far, make sure to subscribe because you won't want to miss the incredible next chapter. Before you go, I want to ask for your help. Every one of my videos is an enormous project that I make by myself in my free time, but I want to be able to divert more time and energy to videos like this, and your support can make that happen. The best way you can do this is by helping boost my videos with the algorithm. Liking, subscribing, commenting, sharing all really make a massive difference. My goal is to get to 100,000 chemistorians by the end of 2025, so if you've made it this far and you want to help out the channel, I'd really appreciate your support. Also, if you're looking for more chemistorian content, check out my Patreon to unlock perks such as exclusive bonus videos. ad-free videos, early access, behind-the-scenes updates, Q&As, and more. I'll also be posting the full, unedited interview with the lovely Davis Nobel over there for the Chemistorian Podcast Episode 2. So head over to Patreon to check all that out. Thanks again to Dava for all her help in making this video. Her biography on Marie Curie is out now, and it's definitely worth checking out. Thanks for watching, and I'll see you in the next one.